Here we look at the solutions to problem set 11, which are on volumes and areas. These are basically the same as last week's problem set. And since this week's lesson is more about giving an overview of volumes and areas. So last week and this week's problems are the core type of volume and areas questions. There we deal with standard geometric objects. So what's the area of a circle? What's the volume of a sphere? Each of these regular geometrical objects has been studied and formulas have been developed. So we know the area is the length squared for a square. The surface area is so and so. So all the different things that we want have formulas. We have expressions for the surface area, the perimeter, the volume. So the questions are ones where basically we say we're dealing with this type of object. So then you know which formulas to use, and then we tell you what the value of the parameters in the formulas are. So the area of a circle is pi r squared. So we say, what's the area of a circle with radius 3 meters? So then you go, okay, the radius is 3, so r is equal to 3. We plug it into the formula, we have the answer. So that's the type of question that we did last week and what we do this week. If we didn't cover those topics, then we really didn't do geometry. People would go, you can't work out the area of this room or this house, the volume of the house. What kind of topics or what type of material did you do? So this is the core part of geometry. So it makes sense to spend 2 weeks doing that, and also having done this week's lesson, because there we give the bigger picture, the framework, which I can just do a quick revision of. So, one, what we've just been doing, using the standard geometric objects. 2, which we'll do next week, is compound objects. So there you have an object where you look at it and go, oh, the base is a rectangle, then the top part is a sphere, that looks like a pyramid. So we break down the thing that we're working with into regular geometric objects, the kind that we've been working with last week and this week, the kind that appear in the tables book. So we do that next. Then there's the topic of nets, where you basically work out what the surface area is, or the way I think of it, it's the minimal wrapping of paper that you'd need to wrap something. So you just look at the shape, the object you're dealing with, and you have to kind of go, okay, that Smarties tube is like, the body is, you can wrap that with a rectangular piece of wrapping up paper, and you need the two circular bits at the end. So that would be your net. You just have a rectangle with two circular bits. We'll be looking at that. And then there's the trapezoidal rule. That's a numerical method. So with that, you'll get an approximate answer, but you're able to work with irregularly shaped objects. So say you're working with something which isn't a square, which isn't a circle. The trapezoidal rule gives you a way to break that down into little rectangular strips and get the approximate area, because most things in the world are not regular geometric objects. So that's basically the gist of this week's lesson. Now I'll just get on to the solutions. What is the area of a triangle with sides 3 meters, 4 meters and 5 meters? Note, I don't need to say that this is a right angle triangle or an equilateral triangle. All I know is that the lengths of the sides are 3 meters, 4 meters and 5 meters. And we can do that using Heron's formula, which is in the tables book. And looking it up on the web, you can derive Heron's formula using Pythagoras. I always think it's a magical formula because it doesn't seem clear or obvious to me that just knowing the lengths of a triangle is enough to work out the area. But anyway, so the way the formula works is you need to work out S, which is called the semi-perimeter, since it's half the length, half the sum of the lengths of the triangle. So in this case, S is 3 plus 4 plus 5, the lengths of the triangle, divided by 2, and that's equal to 6. So now we just plug it into the formula. So the formula states that the area is equal to the square root of S times S minus A times S minus B times S minus C, where A, B and C are the lengths of the sides. So A, B and C in this case would be 3, 4 and 5. So plugging that, or plugging in the values, we get that the area is equal to the square root of 6, since S is equal to 6, times 3 times 2 times 1. So that's S minus A, S minus B, S minus C. So 3 times 2 is 6, 6 times 6 is 36, the square root of 36 is equal to 6. Though I should have written 6 meters squared because it's the area. What is the surface area of a sphere of radius 7 meters? Well, the surface area of a sphere is 4 pi r squared. So it's not the area of a circle, it's the surface area of a sphere. And that's why the formula is different. It's 4 pi r squared. So now we just plug in r is equal to 7. So that's equal to 4 pi 7 squared. Multiply that out and you get 196 pi meters squared. I remembered it this time. What is the volume of a cylinder with radius 3 meters and height 8 meters? So kind of like that Smarties tube. So radius 3 meters, height 8 meters. We look up the expression in the tables book, and so the cylinder volume is pi r squared h. Now just plug in the values. So r is equal to 3, h is equal to 8. So that's equal to pi, 3 squared times 8. 3 squared is 9, 9 times 8 is 72. So it's 72 pi meters cubed. What is the perimeter of a circle with diameter 4 meters? Well, the perimeter of a circle is equal to 2 pi r. Now we're given that the diameter is equal to 4, so the radius is equal to 2. So plugging that in, we get 2 pi times 2, which is equal to 4 pi meters. What is the volume of a ball with radius 7 meters? Well, the volume of a sphere is equal to 4/3 pi r cubed. And we're given that the radius is equal to 7 meters, so we just plug in 7, and that gives us our answer of 1372 divided by 3 pi meters cubed. What is the volume of a cone which is 4 meters high with radius 2 meters at the widest part? Again, we just look up the formula. So the volume of a cone is 1/3 pi r squared h. We know that h is equal to 4 and r is equal to 2, so we just plug those in to get 16/3 pi meters cubed. And finally, what is the surface area of a box with length 6 meters, height 8 meters, and width 12 meters? So basically the same question as we had last week, just with different values. So the box has 6 faces, or 3 pairs of faces. So the total surface area is 2 times the area of each of the faces. So we just go through all 3 combinations. So there's 6 times 8 for one face, 6 times 12, and 8 by 12 for the final one. So that gives us 2 times 48 plus 72 plus 96. Adding those up, hopefully correctly, we get 2 times 216, which is equal to 432 meters squared. So a mistake there, having meters cubed. Remember to subscribe to be updated when new content is added. Thanks.